Hello dear students, today we have to see the practice set 2.1 for of the chapter number 2nd, that is real number of the mathematics part 1st. So before starting we have discussed the introductory part of this chapter, this real number. Now before starting the practice set 2.1 we have to clear first idea of the prime factors of the denominator of a rational number, because this will require to solve the practice set 2.1. okay, and what this topic is, the prime factors of the denominator of a rational number means, if we have taken the rational number a upon b, where as per the definition numerator upon denominator form, where a comma b belongs to I, means what, they are the integers and denominator is not equal to 0, that is b should not equal to 0, or simply that is should be. Then here b, if we take the prime factors of the denominator, the prime factors of the denominator should be 2 or 5 or 2 and 5. If the prime factors of the denominator are 2 or simply 5 or both 2 and 5, then the rational number is, or simply the decimal form of the rational number is terminating. Second one, if the prime factor of the denominator are other than 2, 5, then the rational number, the decimal expansion of the rational number is non-terminating recurring. It has been clear that if the prime factors of the denominator, we have to simply discuss about the denominator only, denominator term, is it is the prime factor is 2, 5 or 2 and 5, or in terms of 2 and 5, then the rational number is of the form terminating. If the denominator is in the form, the prime factors are not in the form of 2, 5 or both 2 and 5, then it is non-terminating recurring. Same topic we will discuss in the form with the examples. Let take one rational number where numerator is a fixed number. Consider it 10 upon 1. What is the division of this number? 10 upon 1 is equal to what? 10. Next, 10 upon 2 is what? Simply 2 1 are 2, 2 5 are 10, that is a 5. Next, 10 divided by 3. If we divide 10 by 3, we will get 3.333 dot dot dot, which is equal to 3.3 dot. 10 divided by 4, it will be what? 2.5. Next, 10 divided by 5, it will be simply 2. 10 divided by 6, it will be 1.666 dot dot dot, which can be given as 1.6 bar. 10 divided by 7. Now we have to do the division of this number. 10 divided by 7 by using the long division method. 7 ones are 7, remainder is 3. Here 3 is less than 7. So what we take as per the rule of the division, take here 0 and give here decimal point. Now 7 4s are 28. Remainder is what? 2. Once you taken here decimal point, then no need to take again decimal point, as we taken here 0. 7 2s are 14. Remainder is 6. Take 0. 7 7s are 49. 7 8s are 56. Remainder is here again 4. Take 1 0. 7 5s are 35. Remainder is 5. Take 1 0. 7 7s are 49. Take 1, remainder is 1. Take 1 0. 7 1s are 7. Remainder is what? 3. Same here it will be repeated, that is 4 2 8 5 7, means here the decimal expansion will be 1.42857 and dot dot dot. Then next number is 10 divided by 8. Here it will be 8 ones are 8, remainder is what, 2. Take 1 0, here give decimal point. 8 2s are 16, remainder 4. Take 1 0, 8 5s are 40. 40 minus 40, that is equal to 0, that is 1.25. Next 10 divided by 9. 9 ones are 9, remainder 1. Take 1 0. Here we have taken 0, so we have to give here decimal point as per the rules of the division. 9 ones are 9, remainder is 1. Take 1 0. 9 ones are 9, remainder 1. Take 1 0. 9 ones are 9. Same way it will be carried out. The quotient will be 1.111 dot dot dot, that is equal to 1.1 dot, and last one 10 divided by 10, which is equal to simply what, 1. Now observe here, if you observe carefully, here the denominator was 2, so we get a terminating decimal expansion. Here the denominator was 3, we get here non-terminating recurring expansion. Here the denominator was 4, that is, then the decimal expansion is terminating decimal. Then here the denominator is 5, here the decimal expansion is terminating term. Here the denominator is 6, here we get the non-terminating recurring decimal. Here the denominator is 7, here what we get, the decimal form as expansion has non-terminating recurring. Here the decimal is, here the denominator is 8, so the decimal expansion is terminating term. Here the denominator is 9, here we get the decimal expansion has a non-terminating recurring. Here the denominator is 10, we get here terminating terms, or decimal form as a terminating terms. So let's observe, here the denominator is 2. At what term we get the terminating terms? Here we take the denominator 2, so here we get as a terminating term as a 5. Again 4, here we take denominator as a 4, so we get here the terminating term. Again denominator has a 5, here we get the terminating terms. Denominator has a 8, so we get a terminating term as a 1.25, and here 10. Simply 2 can be written as 2 into 2, 5 can be written as 5 into 1, again 8 can be written as 2 into 2 into 2. Here 10 can be written as 2 into 5. Means simply what we have to observe, if the denominator, the factors of the denominator are simply, or simply we can use the word as a, if the prime factors of the denominator are in terms of 2 or 5 or both 2 and 5, then we get the decimal expansion of the rational number as a terminating one. Otherwise it will be non-terminating recurring. Here 3 we have taken at the denominator, so we get here non-terminating recurring term. Again the denominator has a 6, its prime factors have 2 into 3, here 2 is there, but as per the condition we should require here 5. If it is 5, then only then it is a terminating, otherwise it is a non-terminating. So here 3 comes, that is the decimal expansion is non-terminating recurring term. In the same way for 7, if we take the 7, we get the non-terminating recurring term. Again if we take the here denominator as a 9, so we get here non-terminating recurring rational number. So let's start the practice set 2.1. First question is, classify the decimal form of the given rational number into terminating and non-terminating recurring types. Question number first, sub question, that is the first one A, 13 upon 5. You have to identify that this rational number is terminating or non-terminating. So what we have discussed, if the prime factors of the denominator are in terms of 2's or 5's or both 2 and 5, then it is a terminating one. So here the prime factor, that is here the denominator is is 5. Therefore the prime factors of the denominator is simply 5. Therefore it is a terminating decimal form. Here the denominator is 5. So 5 can be written as, the prime factor has 5 into 1, that is equal to 5. So here 5 is a prime number. As per the given condition, 2's and 5 should be the prime factors only. So 5 is here a prime number and also the prime factor. Therefore it is a terminating decimal form. Next one, B, 2 upon 11. Here the denominator of a rational number is is 11. It is therefore its prime factor, so its prime factorization is other than 2 and prime factor, so its prime factorization is other than 2 and 5. Therefore it is not terminating decimal form. Here the prime number 11 can be given as 11 equal to 1 into 11. Its factors are only 1 and 11. So it is not terminating decimal form. Next, third one is 29 upon 16. Here the denominator of a rational number is 16. Therefore the prime factors of 16 are the factors. We have to find the prime factors of 16. It can be given as 2 into 8, we get 16. Again 8 can be given as 2 into 4. Then 4 can be given as 2 into 2. 2 into 2. Then 2 can be given as 2 into 1. Therefore 16 can be given as 2 into 2 into 2 into 2. That is, here 2 is repetitive, that is in terms of 2, that is we can say the prime factors are of 2's. Therefore, the given rational number numerator upon denominator form or 29 upon 16 is a, therefore it is a decimal, therefore it is a terminating decimal form. Terminating decimal form. Next one, terminating decimal form. Next one, upon 125. Here the denominator of a rational number is therefore its prime factors are, its prime factor, we have to find the prime factor of 125. Now 125 can be given as 5 into 25. Again 25 can be given as 5 into 5. Again 5 is given as 5 into 1. Therefore prime factors are, therefore 125 can be written as 5 into 5 into 5. That is, the 125 is given as in terms of 5's. And as per the rule, the condition is what? For the terminating one, the prime factorization of the denominator should be in terms of 2's and 5. So it satisfied the condition. Therefore it is a terminating decimal form. Last question of the first, or simply this type, that is E1 11 upon 6. Here the denominator is 6. Therefore the prime factorization of 6 is given as, therefore 6 can be written as 2 into 3. Here 11 upon 6. Here the denominator is 6. Therefore the prime factorization of 6 is given as, therefore 6 can be written as 2 into 3. Here 3 comes. Therefore the prime factor is other than 2 and 5. Therefore it is non-terminating recurring decimal form. Here the first question ends.